Hello everyone, I'm Dr. Julian and I'm thrilled to begin this journey with you into the heart of modern physics. Today we are going to shift our perspective from stuff to fields to understand what the universe is truly made of. Most of us grew up thinking of atoms and particles as tiny solid billiard balls bouncing around in empty space. While that's a handy model, it doesn't capture the full picture of how the universe actually works. To get closer to the truth, we need the concept of a field. Think of a field like the temperature in this room or the wind speed outside. At every single point in space, there is a value assigned to it. It's not a single thing in one spot, it's everywhere. The core revelation of quantum field theory is that these fields aren't just mathematical abstractions. They are the fundamental building blocks of the universe. Everything you see is essentially an excitation of these underlying fields. Let's look at how these perspectives differ. In our comparison chart, notice that while a particle-based view focuses on isolated discrete points, the field perspective emphasizes continuity and how energy interacts across the entire fabric of space. This shift is the key to unlocking everything we'll discuss today. Welcome. Imagine this grid is the invisible fabric of the universe. Every point is connected to its neighbors, forming what we call a field. This slider controls how fast we jiggle the field at the center. In physics, this determines the energy level of the vibrations. Notice how energy moves outward like ripples on a calm pond. Even where the field looks empty, it is vibrating with energy. Field tension is like the stiffness of a trampoline. Increasing this makes the field react more quickly to disturbances. With higher tension and frequency, the waves become much sharper and travel across the grid at higher speeds. Use the impulse slider to give the field a single kick, and watch how that lone packet of energy travels. Building on that kick we just gave the field on the previous page, let's look at what that pulse actually represents in our physical world. In quantum field theory, we move away from the idea of particles as tiny solid marbles. Instead, we define a particle as a localized vibration or an excitation. It's a point where the energy in the field is concentrated enough to manifest as something we can detect. To visualize this, let's watch how a pulse emerges from the fabric of the field. Notice that the pulse isn't a separate entity. It's the field itself doing something specific. This brings up a beautiful realization. Every electron in the universe is identical because they are all made of the same universal field fabric. As you see here, an electron is a ripple in the electron field, while a photon is just a ripple in the electromagnetic field. They are different flavors of vibration in their respective fields. Building on that mental leap we just took, if particles are ripples in a field, what happens when there are no ripples at all? You might call it empty space. But in the world of quantum physics, the vacuum is never truly empty. In quantum field theory, we redefine the vacuum. It isn't nothingness, it is simply the field's lowest possible energy state. Think of it like the surface of a pond on a very still day. It looks flat, but the water molecules are still there, just waiting for a reason to move. Why can't it be perfectly still? Because of the uncertainty principle shown here. This fundamental law tells us that we can't know the energy and the time of a system with perfect precision. If a field were perfectly still at zero energy, we'd know too much. Nature forbids that stillness. This leads to zero-point energy. Even at absolute zero, there is a residual shiver in the field. This energy isn't just theoretical, it has measurable effects on the universe around us. Look at this visualization. If we could zoom in to the smallest possible scales, we'd see what we call quantum foam. It's a chaotic, boiling sea where virtual particles pop into existence and disappear almost instantly, like bubbles in a carbonated drink. Following our look at the chaotic activity of the vacuum, we now reach a crucial realization. These fields don't exist in isolation. They are constantly talking to each other. In our everyday lives, we think of forces as things that happen between solid objects, but in the quantum world, a force is simply what happens when one field pushes or pulls on another. They are deeply interconnected layers of reality. Look at this visualization. Instead of particles colliding like billiard balls, imagine waves in a pool influencing the movement of other ripples nearby. This is how the grid communicates. Take two electrons, for example. They never actually touch. Instead, they repel each other by exchanging a specific ripple in the electromagnetic field, a photon. It's like a messenger wave telling them to move apart. This leads us to the most elegant conclusion in physics, the unified view. The universe isn't a void filled with separate things. It's a grand symphony of overlapping fields, all vibrating and interacting together in a complex, beautiful harmony. Before we move on to mastering these concepts, I want to hear your thoughts on this perspective. To bring our session to a close, let's step back and look at the big picture we've painted today. We've shifted our perspective from a world of hard particles to a universe of vibrating fields. Remember the core shift we just covered. Fields are the primary reality. The particles we once thought were the building blocks are actually secondary, simply localized ripples in those underlying fields. This means that everything you see is part of the cosmic fabric. Every object and every beam of light is an excitation, a localized dance of energy within a field that spans the entire universe. And while it may feel like a deep philosophical shift, this is backed by incredible science. Quantum field theory provides the most accurate description of reality we have, predicting the behavior of nature with unmatched precision. I'll leave you with this thought. You aren't just a collection of matter. You are a complex, beautiful wave pattern dancing in the fields of the universe. Thank you for your curiosity today. Before we head out, let's hear from Sophie.